All right, now that you've got the PC, the next thing to implement is the fetch logic. So as I showed you before, the shell that we've given you provides an instruction memory instantiation. The instruction memory is constructed to contain the test program that the shell is providing, the same program that you coded up earlier with Kunal. So for this lab exercise, just uncomment that line toward the bottom of the shell, give yourself the instruction memory, and you can also uncomment the CPU visualization. The visualization is going to assume certain signals, and the instruction memory is going to assume certain interface signals. So we're not assigning those signals. Compile it anyway, take a look through the log, and just take a look at the errors that you're getting as an indication of what signals are provided by the instruction memory interface that you're not assigning. And then for the next slide, we'll fix those issues. All right, so now we're going to hook up the instruction memory. So you probably saw errors in the log for these signals, saying they were consumed but not driven, or produced but not not consumed. So we need to provide appropriate hookup for these signals that were introduced by the IMM macro. All right, so you've got, so the IMM inputs are IMM read enable, IMM read address, and for the address here, based on the instructions that you've assembled, we're constructing an array that fits those instructions. And based on the size of that array, you'll need to specify the appropriate number of index bits. And there's this constant that you can use for that. So you can use this expression for the address. Well, this is the range of the address signal that you'll hook up to. And since what we're driving into the address is the PC, right? We're indexing by the PC to look up the instruction, and the PC is a byte address. We are going to assume that the PC properly is aligned to the instruction boundary. So we're assuming that the lower 2 bits of PC are 0, and we don't need to hook those bits up to provide the address. So we want the PC divided by 4 essentially, so you can hook up to this expression for your PC hookup to the address. All right, and the instruction memory then is going to drive out a signal called IMEM read data, and we want to consume that as the instruction, right? This is the instruction from memory. We'll give it a new name, so hook up this instruction signal to the output from the memory, and check your simulation, check your log, make sure everything's properly hooked up. And at this point, you should be able to see your visualization. You should be able to see the PC value incrementing properly. And I'm not sure exactly what you're going to see. I guess you probably won't see the instruction itself until we add the decode logic. So go ahead and do that, and then come back.